All right, let's take a look at this example. We have x squared over 4 plus y squared over 81. Since both of these fractions are positive and they have different denominators, you've got the squares here, that tells us that we're dealing with an ellipse. Now, since the number underneath y is larger, that indicates that we're going to be stretched in a y direction more so than an x direction. And I hope that makes sense to you, because if I look at this and I identify the a, the square root of 4 is 2. If I identify my b value, the square root of 81 is 9. So yeah, we're going to be stretching 9 units in the y direction, but only 2 in the x direction. So because of the form that we have, we can easily identify the center as being the origin, because there is no adjustment made inside the square for the x or for the y. All right, so if I want to do a quick sketch of this just to get an idea about where things are, well, that isn't a vertical line. Better. All right, so my center is the origin. For the x, I'm going 2 units to the right, 2 units to the left. But for the y, I'm going up 9 units and down 9. Again, this is not the prettiest graph we're ever going to see, but it gives us a good idea about where things are, and it helps us answer our questions. So 2 to the right and to the left. 9 up, 9 down, and then we have our ellipse. All right. Now, because we're stretched more in the y direction, that means that our foci are going to be up and down from the center, not left and right like in a previous example. So how do we figure out where those are? Well, we go back and we calculate what c is. Now, we know the formula is that c squared is going to be the difference of these two guys. So it's going to be 81 minus 4. You might say, well, I thought in another video you would have done 4 minus 81. Remember, I'm going to be doing the absolute value anyway, so I just need to find the difference between these and make it positive. So if I say 81 minus 4 or 4 minus 81, I still need to do the absolute value. And so I'm just going to go ahead and do this because I know that, of course, 81 is larger. So when I do the subtraction, it's just fairly simple. All right, so 81 minus 4 is 77, which means that c is going to be the square root of 77. You try to simplify if possible, but you can't do anything with the square root of 77. All right, so identifying the foci, the c here is going to be changing you in the y direction. So that means your x value is going to stay the same, but your y value is going to be up or down by the square root of 77. Now here's something to kind of help you out. Sometimes you might get confused about whether or not you're supposed to add or subtract the a squared and the b squared. Well, think about this. If you were to add these guys, 81 plus 4 is 85. And the square root of 85 is something a little bit larger than 9. Not much larger, but it is larger than 9. But that means that would put your focus, remember the focus, that c value tells you how far away from the center you are for the focus. And if I had the square root of 85, which is larger than 9, that would put your focus somewhere out here. But as we said in a previous video, the focus must always be within the curve. It must be inside here or here or here, wherever it happens to be. It has to be inside the curve, not outside. All right, so let's talk about the vertices. Remember, the vertices will always be along the major axis. In this case, the major axis is the y-axis. Again, we're stretched in the y direction. So that means our vertices are 0, positive 9, and 0, negative 9. Simple enough. And then we want to find the length of the major axis, which, again, is going to be double, in this case, double the b value, because that's the longer one. So the length there is going to be 18. And then if I do the length of the minor axis, that's when you're going side to side here, because that's the shorter one. So it's 2 here, altogether that's 4. And we also want to add in the endpoints of the minor axis. All right, we can clearly see that we shifted off from the center 2 units in either direction. And so that gives us the order pairs 2, 0 and negative 2, 0. All right, then the last thing we have left to discuss, as long as I'm not forgetting anything, is going to be the domain and the range. So my domain, as you can see from the picture, is from negative 2 to positive 2. And again, even if I didn't have the picture, if I didn't have something where I could, draw all the tick marks here, I should still be able to come up with a fairly decent representation of the graph, knowing where the center is and knowing how far I've stretched in the x and the y direction. My range value, or my range values, you're at 0, but you go 9 below, you go 9 up. So that means you're going from negative 9 to positive 9. And there you go. You can answer a whole bunch of little questions about this, right? The toughest thing here really is to identify the C and make sure that you know in what direction you're going for that. So the square root of 77 is going to be really close up here. So you have a focus up here and another focus down there. They will be within those curves, like I told you, right? In this case, they're stretched really, really far away from the center. Now, the closer these foci get to the center, the closer and closer your shape is going to start to look like a circle, right? And if they were ever to be right on top of each other, well, you wouldn't have an ellipse, you'd have a circle. All right, let's do another example. Let's try this one. We'll take x plus 2 quantity squared over 9 plus y minus 4 quantity squared over 25 equals 1. Perfect setup for an ellipse. Both of these fractions are positive. Denominators are different. You equal 1. Okay. Now, if for some reason this wasn't equal to 1, and you had other numbers running around in front of the parentheses, divide by whatever the number is over here so that it is a 1, and then you should be able to pick off what the a and b values are from here. So from here, if it's 9, that means the a value is 3. Again, just take the square root. 25 means my b value is 5. All right, so the center is not going to be the origin anymore. The center is going to come from the pieces that you see inside the x and the y. Now, I'll make it very clear to you. Whatever's inside with the x, that contributes to the x-coordinate of the center. Whatever's inside with the y contributes to the y-coordinate, just like it was when we were identifying the vertex for the parabola. But we have to do the opposite of what we see. So I see positive 2, so the center is going to be negative 2. Instead of negative 4, we'll say positive 4. That's my center. And the a and the b here just indicate how I've been stretched in the x, 3, and the y, 5 direction. All right, so that means we're stretched more in the y direction from this center. So let's see what our graph looks like. We're going to the left, 2, and up, 1, 2, 3, 4. There is my center. Don't make a solid point. It's just a reference for us. Your a value is 3, which means I go to the left, 1, 2, 3, and I would have a point. I would go to the right, 1, 2, 3, and I would have a point here along the minor axis. Now, why is it minor? Well, because the value that's underneath the y is larger, which makes that the major axis, which means we'd be going up and down 5 units. So from here, 1, 2, 3, 4, 5. There we go. And going down 5, so 1, 2, 3, 4, 5. Now, if you have graphing paper, it'll make this a whole lot easier to see. And then we just connect our dots the best we can. Again, it's almost like you're drawing a circle, you're just stretching it out. All right, so there's the center. And as we've done before, let's talk about the foci. But to talk about the foci, we've got to find out what c is, right? So start with c squared. C squared is the difference of these two guys here and here. Do the large one, and then minus the small one. So 25 minus 9 is equal to 16, which means C equals 4. And remember that C value is used to determine how far off from the center your foci are located. So since it's 4, and we're stretched in the y direction, that means we could go up 4 units here to have one focus, and then go down 4 units here to have the other focus. Now, as long as your graph is accurate, we shouldn't have any problems identifying the actual coordinates. However, we can use algebra to make sure that whatever we have is just spot on, right? So we're moving up and down 4 units from your center. So if I go up 4 units from here, I get 8. If I go down 4 units from here, I get 0. So you can see how that matches up with my picture. Then we talk about the vertices. Now, the vertices, again, are along the major axis, which is going to be the axis along which you are stretched. So that's stretched in a 5 because that's the larger number in a y direction. So that means for my center, I'm adding 5. So -2, 4 plus 5 is 9. And if I take 5 away from 4, I have -1. So we can try to bank on my graph being nice and accurate. But what if your graph isn't accurate? Or what if the numbers are so large or just kind of weird and wonky that's kind of hard to really see what it is? You just have to know how you're moving, right? So this 5 means you're moving up 5 units and down 5 units from this. That means you're changing your y value because we said up and down. You go up 5, and you take this and you go down 5. And you're done. All right, so now let's go to the length of the major axis. Well, the major axis is the one that we use the 5 for, so double that and we get 10. And then the length of the minor axis is going to be double the shorter guy. So 3 times 2 is 6. And while we're here, we'd like to talk about the endpoints of the minor axis. The change here is 3. And since the minor axis is along the x direction, we're going to take this guy right here. We'll add 3 and subtract 3 from that. So adding 3 gives us 1, +4. And subtracting 3 gives me -5, +4, which you can see that showing up here in my picture. Here's -5, 4 for one of those endpoints, and the other one here is 1, 4. Finally, let's talk about the domain. The domain, as we go from left to right, and this is where having a picture is very helpful. Your x is going from -5 on the left to +1 on the right. So bracket -5 to +1. Now, we could also see that with our picture, that the minor axis is along the x direction, and so that's where we can find our starting and ending values. But then for the range in this case, since we're stretched in a y direction, will be connected to those endpoints for the major axis. In other words, the vertices. And these are the y coordinates for those vertices. So that indicates that your range is going to go from -1 to +9. And there you have it. Get a good picture, find your C value, and you can answer everything else. Even if the numbers are a little bit weird. Let's see what that looks like.